Hi students, this video is going to explain how to solve these 4.2 word problems about mechanical advantage and mechanical efficiency. Those are some of the new equations from this part of the book, or this part of your notes. I'm going to start off by writing out the helpful equations up at the top of my page. You remember this one from before? Work equals force times distance. A new one for 4.2 is mechanical advantage equals output force divided by input force. Remember, mechanical advantage is how much the machine helps you do the work. So of course it makes sense that the output force is going to be greater than the input force, and if this number is greater than the output force is greater than the input force, then that will leave us with a number greater than 1, and if our machine is helping us by making work less, we want our mechanical advantage to be as high as possible. The last equation that we'll need for this worksheet is mechanical efficiency, which is equal to output work divided by input work, multiply that by 100, and we're going to multiply it by 100 to give us a percent. This one makes sense because output work is going to be greater than input work, because some of the work that you input onto the machine will be lost due to friction. So the numerator would be a little bit smaller, or in some cases a bit smaller depending on how efficient the machine is, but the numerator will be smaller than the denominator, which will give you a fraction. You'll multiply that number by 100 to get a percent. So number 1 says, I need to move some soil up 10 centimeters, but when I use a shovel, I move 40 centimeters. Does the machine make the task easier or harder? How much, how many times easier or harder? Well, you know, or you may recall, that the force distance trade-off says that the more distance that you cover, the less force that you need to apply, right? Because work equals force times distance, and anything that we're trying to do, would it be accomplishing the same job or the same work, when I increase the amount of distance, I'm going to then have to decrease the amount of force to end up with the same product of work. So, because I move 40 centimeters and the soil only moves 10 centimeters, more input distance moved means that the job is easier. How much or how many times easier? Well, that's going to depend on how much more I moved. Because 40 is 4 times more than 10, right? 40 divided by 10 equals 4. So the job is 4 times easier with the shovel. So that gives us a mechanical advantage of 4. Number 2. If I apply 25 newtons of force to the shovel, how much force does the shovel apply to the soil? So we're looking back at this work equals force times distance equation. We know that when we've increased the amount of distance, however much we've increased the distance means that the force is that many times less for our input. So if we input 25 newtons of force, the machine is going to make that job 4 times easier. So 25 newtons of force times the 4 times mechanical advantage, from this question number 1 that we just solved, 25 times 4 means that the shovel is applying a force of 100 newtons to the soil. My scrolling is a little messed up here. Number 3. I have 2 options to get a box into the back of a truck. Below. Here are the 2 options. Please explain why I might decide to use either option, meaning there are advantages and disadvantages to both, and other variables to consider. So option 1, I'm trying to get a box into the back of a truck. Option 1, I can use a ramp that's 10 meters long. Option 2, I can pick up the box and move it into the back of the truck 1 meter off the ground. And you can think right now, 1 meter is a little bit longer than 1 yard. When you moved your mousetrap car, it had to move a distance of 5 meters. So right now, try and think about how far 1 meter is versus how far 10 meters is. 10 meters, that's a really long distance. That's twice as far as your mousetrap car had to travel. That would be the size of a pretty big room in your house, probably, maybe even a hallway or longer. So I can use a ramp that's 10 meters long. Again, that's a really far distance. This 10-meter long ramp, thinking back to question number 1, it's 10 times more distance, so that means it's going to make the job 10 times easier. It's going to need 10 times less force to complete this task. However, 10 meters is a really long distance, so a disadvantage to this might be that you have to cover a large distance. Maybe 10 meters is just really far. The box isn't that heavy. Maybe I'm able to just pick it up. It doesn't say in here how heavy the box is. Maybe the box is easy enough to just pick up and only move 1 meter. That's probably shorter than most counters in your house. So if it's light enough, easy enough, that might be a quicker option. So time maybe is a factor here. I can do it a lot faster if I just have to pick it up 1 meter. But if it's really heavy, you might not be able to pick it straight up. Maybe you need to push it up that really 10-meter long ramp. So, option B, to pick up the box and move it 1 meter, it makes the job harder. Right? 10 times more difficult than if you were using ramp. But it might save some time if the box is light enough that you don't need to use the really long ramp. Oh, and looks like I just answered question number 4 down here. Does the ramp make the above job easier or harder? Ramp makes the job easier. How do you know? More distance covered means that there is less force needed. How many times easier or harder? 10 times easier, because the ramp is 10 times longer than vertical distance. Number 5. A screwdriver is used to open up a paint can. You apply 7 newtons of force to the end of the screwdriver and move 4 inches. The tip of the screwdriver moves 1 inch and applies 28 newtons of force to the paint can lid. What is the mechanical advantage of the machine? So here we have our paint can. Suppose I should have pasted an image in here beforehand. But hopefully you can see that this looks well enough like a paint can. And here is the screwdriver with the handle. And if you've ever done this before, you know that the very tip of the screwdriver, you place it underneath the lid of the paint can, and you're just prying it a very, very, very short distance. In this case, it's 1 inch. You are going to move the handle on the screwdriver a much larger distance, in this case 4 inches. Okay, so if you can imagine, if you were trying to do this with just your fingernail, that would be kind of painful to get your fingernail to pry underneath the paint can lid. If it's a fresh can of paint from the hardware store and it's sealed really well, I don't think that would be possible without kind of hurting or breaking your fingernail. So you're going to use a screwdriver to pry open the lid. Okay, so the screwdriver tip moves 1 inch up. I guess these arrows are backwards. You're going to move the screwdriver tip 1 inch up, and you're going to move the screwdriver handle 4 inches down to get this prying action. Okay? The tip of the screwdriver moves 1 inch and applies 28 newtons of force to the paint can lid. Question again here is, what is the mechanical advantage of the machine? Well, if we remember from up here, our equation for mechanical advantage is output force divided by input force. The output force, that's what the machine does. That's 28. Output force divided by input force. Output force is 28 divided by input force, which is 7. 28 divided by 7 is 4. You might also have noticed, and this is on purpose, that the number 4 is a common theme here. You could also say that mechanical advantage is equal to input distance divided by output distance. And it's really important to get the order right here. You'll notice input distance divided by output distance. Over here, this is the opposite. Output force divided by input force. Both of these equations will give you mechanical advantage. This makes sense, right? Because you know the less force that you apply, the easier the work is. The more distance that you cover, the easier the work is. Right? When you move more distance, the mechanical advantage is higher because the job is easier. When you apply less force, the job is easier, the mechanical advantage is higher. So input distance in this case is 4 inches divided by the output distance. The screwdriver tip only moves 1 inch. So 4 divided by 1 gives you also a mechanical advantage of 4. Number 6 says, The above question demonstrates an ideal machine, where none of the work is lost to friction. In actuality, the screwdriver applies 26 newtons of force to the paint can lid. What is the mechanical efficiency of the machine? In this case, a screwdriver. Well, as you may remember, an ideal machine doesn't actually exist. At least not in the real world. In some cases in science problems, like in number 5, we'll ignore friction to make the problem a little bit easier, but it's important to understand that in a machine, not all of the work that you do is converted into the output, so meaning that input is always going to be bigger than the output, because some of that work is lost to friction. In some cases it makes sparks or lights or heat, but in any case you need to understand that the input work is always going to be a little bit more or a lot more than the output work. And then we know from our notes the equation for mechanical efficiency is output work divided by input work, which will give us a decimal, so we're going to multiply that number by 100 to give us a percent. So mechanical efficiency equals output work divided by input work times 100. Output work, just like any work equals force times distance. The output force given to us in the problem is 26 newtons times the distance that the screwdriver tip traveled, which from the last question is 1 inch. Output work, we're going to divide that by input work, which again is force times distance. The force that we apply from question number 5 is 7 newtons times the distance that we move the handle from the last problem is 4 inches. 26 times 1 is 26. 7 times 4 is 28. This is work, so the unit is joules. Get out my handy-dandy calculator. 26 divided by 28 gives us 0.928. We're going to round that to 0.93. Multiply that number by 100, which gives us 93%. So, in actuality, this is a pretty efficient machine. Most of the work that you do is being converted onto opening up that paint can lid.